All right, we're going to use this plate motion simulation to help us learn a little bit more about what exactly happens at the types of plate boundaries, such as convergent, which is when two plates go together, push towards each other, colliding, divergent, where they're dividing or pulling apart from each other, and transform boundaries, where the two plates are sliding past one another. So there's some things that happen at each one, and we're going to watch some simulations to make predictions about what is going to happen. So let's start here with convergent boundaries. We're going to click See Plates Over Time, and let's take a look at what we're looking at here. So continental lithosphere, you can see here is this kind of tan color. There's no oceanic lithosphere here. There's not any melting rock right now, but we do see the mantle, and we see the yellow arrows, which are going to show us convection currents. The convection currents are that circular motion due to change in temperature, density over time, moving the mantle around and therefore moving our plates on top of Earth, which is the theory of plate tectonics. We're going to be on the lookout to see if we see any of these things form: earthquakes, mountains, volcanoes, underwater volcanoes, rivers, or abandoned riverbeds. So a convergent boundary, again, is where a boundary where two plates collide. So let's chat quick about timing. We can see from 10 years to 20 million years. And we spent a lot of time this year talking about how, weathering, erosion, deposition, and now plate tectonics, they take millions and millions of years to see some dramatic changes. So when we look at something for 10 years, you can't blink. You might miss it because it's really only moving, maybe an inch or so every single year. Over 10 years, that's not a ton. So if we reset time, we're going to check out 20 million years for each of these simulations because that's when we can really start to see changes. So in this case of a convergent boundary, what do we predict? Take a moment. I'm going to kind of count in my head for 10 seconds to let you think about what do you predict is going to happen if these two plates are going to get pushed together and collide. All right, let's see if your prediction is accurate. So carefully observe as we're watching. We see the convection currents moving downward. We see earthquakes. We see the land in the middle start to get a little bit thicker, a little bit wavy. Some bumps start to form on top. Formation into hills. Earthquakes are pretty consistent. And over 20 million years, those hills become mountains. So not only is it getting pushed up, it's also getting pushed down because the continents or the continental crust getting pushed together has nowhere else to go but up or down, forming mountain ranges over time. So that question just kind of popped up there is, what if two oceanic plates collide? So we have a different situation here because we're now looking at oceanic lithosphere or oceanic crust above our mantle, our asthenosphere with the convection currents. And it might be a little bit different because they're two different types. And we know that oceanic crust is more dense than continental crust. So let's see what happens. Let's watch for 20 million years. We have earthquakes as always. And we start to see that if one oceanic plate is more dense than the other, it's going to subduct or sink under the other. That rock starts to melt, and that magma gets pushed up through the crust and starts to form underwater volcanoes, which start to form above ground volcanoes. And eventually, that movement of converging pushes those two plates closer and closer together, creating some new rock and new volcanoes above the surface. Which is pretty cool. At a place where two plates are colliding or converging, you can also get something called a deep ocean trench. So when one plate gets sucked underneath the other one, it kind of creates a gap, creating a deeper hole where those two things. So one of your vocab words was also deep ocean trench. All right, let's go back to the beginning and check out divergent plate boundaries. So again, this does make a difference depending on whether you're in the ocean or on continental land or what two plates are interacting. So this again here, the light color is continental crust or continental lithosphere, which is going to be different than if two oceanic plates collide or divided. So let's check out 20 million years. I'm going to pause for 10 seconds to help you give you some time to make a prediction of what's going to happen to the land in 20 million years. Make a prediction. All right, let's see if you're right. We have earthquakes. The convection currents are moving in the opposite direction, and instead of pulling the things together, it pulls the plates apart. That crust starts to get thinner and thinner in between, and then eventually it leaves space for magma to move up. That magma cools, hardens into igneous rock, forms some underwater volcanoes, which eventually will surface. And we also get that rift in between the two continental plates forming with water because it's kind of created a depression where water can actually fit over time. Now, if these were two oceanic plates that were diverging, you would get the creation of something like a mid-ocean ridge, which is a mountain underwater, and that process is therefore now going to be called seafloor spreading because you're going to be creating new ocean floor. So it depends on the situation, what two plates are interacting. Okay, last one, a transform boundary where they slide past each other. So we have two continental plates, continental crust, in a transform boundary situation. And we also have a river flowing across both of them. So you can see the arrows, one's going to move up, one's going to move down. I'm going to give you about 10 seconds to think of your own prediction. What are you going to see happen in a transform boundary in 20 million years? Make a prediction. Okay, if you have a prediction, let's see if the prediction is correct. Remember, transform boundaries, they get lots of earthquakes. If you are living near a transform boundary, earthquakes are going to be a part of your regular yearly life. If anything is crossing that transform boundary, anytime there is an earthquake or there's some movement there, that stuff is going to start to get displaced. In case of a river, it might have to forge its new path like you just saw happen there, and then part of the river will get kind of abandoned over time. So you'll see some small changes anytime a transform boundary is moving, but eventually, over 20 million years, you've got a pretty big change in that river, where it started versus where it is now, and lots of earthquakes along the way. So those are your three types of boundaries, and now you are going to be exploring those boundaries a little bit more through looking at some diagrams to help you with your drawings and analyzing those diagrams.